All right, so I think we'll go ahead and start. So my name is Nader Dabit. I work with AWS. I've come here to Portugal, especially for this conference, and it's my first time in Pixels Camp, but I've been to Lisbon one other time. The name of my talk is Build Fast and Make Things. I'm going to be going into quite a few different topics here, but I'll save the details for later. But the team I work on is known as AWS Mobile, and it's a team that's really focused entirely on building or enabling front-end developers really to build cloud-enabled applications. Typically, when people think of AWS, they think of back-end or servers, they think of infrastructure, DevOps, that sort of thing. But our entire team is actually focused on building front-end tooling. So I'm going to talk about some of that stuff today. You can find me on Twitter, on Medium, and on GitHub at Dabit3. I am involved in a couple of other things other than AWS. I'm the author of React Native in Action by Manning Publications. I'm big into the React Native community. I have a podcast called React Native Radio. I have an open source project called React Native Elements. That's within the React Native Training organization. React Native Training is also my company. We do React Native and React training for large companies. So the main core of what this talk is about is developer velocity. How can we use our existing skill sets to build our applications in the most efficient manner in the fastest way possible with the least amount of friction? And I'm going to be introducing this term that I'm calling full stack serverless. And it's basically a combination of front-end, back-end, and DevOps. And it's really focused and geared towards developers that are kind of in the JavaScript ecosystem, and maybe even some Python. So considering we're talking about front-end, back-end, and DevOps, I'm going to kind of go through each of those and kind of look at the state. So what is the state of front-end development right now? Well, it's getting more and more complex. Just a couple of years ago, maybe 5 or 6 years ago, you could probably get by with just HTML and CSS and be considered a front-end developer, or maybe a little bit of jQuery. It's gotten a lot more complex over the last few years. As all of us probably know, we've dealt with a lot of these things here. A lot of new JavaScript frameworks came out over the last 6 or 7 years. We've kind of focused now on Angular, Vue, and React. Those seem to be the ones that have kind of held their own. We're not seeing as much disruption in that space right now, but we still have to deal with a lot of other things. Data architecture, GraphQL is becoming really big. Understanding how to deal with GraphQL on the front end, dealing with CSS in general. There's all different types of ways you can deal with CSS. But the bottom line is front end is getting more and more complex. And a couple of the reasons behind this are single page applications are getting more and more popular. People are getting used to high quality single page applications, so the user expectations are going up and up. Because of the single-page applications, the way that we build those, we have more complex data concerns. And people are using multiple devices to access the same data. So we're having all these different data access patterns across different devices for the same backends. Mobile development, it's always been hard, but now the user expectations are still going up. But we're seeing a few things that are expected now in most mobile applications. A lot of times, they want their applications to work offline. Real time is becoming more and more prevalent, more and more common. The same with the complex data concerns and performance. People want their applications to work whether or not they have a good connection, regardless of what their connection is. What we are kind of seeing, though, in the mobile space, especially I've seen a lot of this with React Native training, is people are taking advantage of cross-platform a lot more and more often. A lot of big companies, Microsoft, Amazon, Salesforce, American Express, Visa, we've worked with most of these companies, and they're taking a cross-platform first approach. So instead of saying, hey, we have this application, how can we build it in iOS and Android on 2 separate teams? They're exploring Xamarin, React Native, Flutter. Can we build this in one of these? And if the answer is yes, they do it. If not, only then do they go to the native solution. So, with the rise in complexity, a lot of people ask this question: how can we still be a full stack developer? Is that even like a term that can be like used in general? Because how can you be specialized in all of these things and be very good at those? Because if you want to be good at your job, you want to be very, very good at everything you're doing. So how can you understand all of this stuff? But I think that's the paradox of what is happening in the software industry right now. Yes, you can be, and I think that what I'm about to show is the evolution of what's happening in this space. So what about the back end? A long time ago, we dealt with our infrastructure on premises. We had to deal with things like outages in our service. We had to deal with things like we did not have ways to cache. If someone on the other side of the world is accessing our information, they were traveling entirely across the globe. There wasn't anything like edge computing, any of that stuff, no CDNs. We also had to deal with weather. So what happens if our building gets destroyed by a tornado in Mississippi? And then next we moved to the cloud. Cloud computing became a thing. We still have to deal with scaling, but we don't really have to deal with server patching, server management, all of those sort of things. And then next came the idea of serverless, and this is going to be kind of where we're focusing today. And this is kind of another level of abstraction, and we no longer are having to deal with the server maintenance, server uptime, server patching, and we're also not having to deal with the scalability. And serverless continues to grow, and there's a lot of different ways that people kind of talk about serverless, and I'm going to go over the definition of what that is in just a second. But what's the answer I'm trying to show today is what comes after serverless. What's the next big thing? I'm big into futurism. I love watching the people that are labeled as futurists. They always have these wild and crazy ideas. Usually the crazier their idea is, the better of a futurist they are to me. 90% of the time, the stuff that they're talking about is like way off in left field. But a lot of times, you can kind of like feel their energy and get what they're talking about. So I'm kind of talking about what I think is the future. So what is serverless? And serverless is started off as Lambda functions, right? Like that was the original term that people used as serverless. But now it's actually, people are using this term to mean a million different things. Recently, Berkeley came out with a paper, Cloud Computing Simplified, a Berkeley view on serverless computing. And it said this: while cloud functions packaged as functions as a service offerings, or FaaS, represent the core of serverless computing, cloud platforms also provide specialized serverless frameworks that cater to specific application requirements as backends as a service offerings. So basically, they're defining serverless as a combination of functions as a service as well as backends as a service. So it's no longer, in their definition, just these functions, but they're also adding in these managed services, backends as a service. Also, another definition that I'll go over is Chris Munns. He's another technical evangelist at AWS. He spoke recently at Serverless Days Austin, and he focused his talk on, instead of the definition of what serverless is, we should be focusing on how we can deliver value, and we should be focusing on what we're seeing to be the new way of modern application development. So what is modern application development? His definition was a greatly reduced operational burden, tighter alignment to cost with usage. The most interesting thing to me was this third, is that developers can, could, and should be able to do almost anything. And he had a note there that said, this is an understated warning to ops, DevOps, and SRE-ish type of people. This is super interesting, and this is going to be something we're focusing on in just a moment. Also, opinionated platforms that allow for multiple use cases and true best practices and best of breed practices. They bring all of those aspects delivered to you. There's also this person that I follow on Medium and on Twitter. His name is Ben Kehoe. He is really, really insightful. He runs the infrastructure at iRobot. iRobot creates or has these what are these little vacuums? I forgot what they're called, but they're really popular. Roomba. So they make the Roomba. They make all these different things. Anyway, he has a blog post called The Serverless Spectrum. And he says, like so many things in life, serverless is a spectrum with multiple dimensions along with which they can vary. So for a service to be more serverless, it needs to move in one or more of the following directions. Serviceful, which is something I'm going to talk about too in just a moment, plus ephemeral compute. Ephemeral compute is the serverless function. Tighter correspondence between resources used and resources billed, and smaller and more abstracted control plane. So serviceful, what is that? So Patrick DuBois coined the name serviceful at Serverless Conf #1 in Brooklyn in 2016. And he defined it as this: as an application becomes increasingly serverless, it relies more and more on external services to provide the building blocks of the system. So we'll really dive into that. Serviceful would be, this is the characteristics of a serviceful application. It inherits all of the serverless characteristics, the 4 in white. No server operations, scales seamlessly, no need to manage uptime and variable expense. But we also are going to be adding these 2 characteristics, codeless. These managed services, these serviceful services are essentially codeless in the sense that you're not owning any of the code. All of that code is now owned by the service provider, whoever that is. Doesn't have to be AWS. I should mention, everything I'm talking about is not specific to AWS. Microsoft, Google is coming out with a lot of this stuff. A lot of other companies are doing this stuff. And then second, they assume responsibility for providing a defined set of services. So Ajay Nair is the head of product at AWS Lambda. He's a really, really smart guy. And he says that we aren't living in the day and age where every architectural primitive fits into this model, but it's heading in that direction. In cryptography, there's this popular saying that keeps being repeated, and it basically says this: don't roll your own crypto. In the web development world, we do the equivalent of rolling our own crypto every day, though. Instead, we should kind of let the experts handle all this really hard stuff. It's incredibly hard to get right, and there are 1.5 million ways to mess it up. And really, it's the service provider's purpose in life to be good at this one thing. And they also have economies at scale that we really don't, typically. So what are some examples of these serverless, serviceful services? Algolia is a search service that's out there that's really good. Cloudinary does media management. Auth0 and Okta do authentication. There are literally thousands of these services out there. This is just a few of them that I'm highlighting because these are more well-known than the others. And then on the bottom are some of the AWS services that we offer. AWS AppSync, Amazon Cognito. I'm going to be going over both of those today in a demo in just a moment. Amazon Lex and Amazon Recognition are really popular. Recognition is a machine learning service for video and image recognition. You basically pass in an image or a video. It returns a JSON object with data about what's in that image or video. Some other ones that we offer at AWS that I'm going to be going over about half of these is in a demo. Authentication, which is Cognito. Search, a couple of different ways you can do that. AppSync or Elasticsearch. I'm not going to go over all of these, but this is just a subset of some of the ones that we offer. And so what are the drawbacks of doing this type of architecture? The number one that people have bad feelings about is the vendor lock-in. So a lot of the times when you're going with a lot of this stuff, you're kind of like tied to that vendor. Your cloud functions, your serverless functions, those can really be ported over to other vendors, but as far as like dealing your authentication or doing AppSync, writing your resolvers, things like that, you're kind of tied to that provider. You can move it away, but it just takes a lot of work. You also have a lot of increased risks when you don't have any control over this infrastructure. So if it goes down, you can't go and fix it. It's someone else's problem to deal with. And then the feature set is defined. You may be able to submit issues, submit feedback about what you would like to add, but at the end of the day, it's not up to you to add these features. It's kind of up to the cloud provider. So basically, the workflow that I'm proposing is this. You get a feature, you first decide, can this be offloaded to one of these managed services? If it can, then do it. If not, then use a Lambda function. At the end of the day, you're kind of doing this, all of this to do really one thing, is delivering value for your customers, delivering value for your users, and you're not reinventing the wheel, creating things that are very easily abstracted away. So full stack serverless, that's what I mentioned earlier. What are the characteristics of building in this way? The three that I would really focus on, in general, that we're going to dive more on in just a second. A thick client handling interaction logic, heavy use of managed services, and then the serverless functions are just filling in the gaps for whatever the managed services can't provide. And code is a liability. It's taking the direction of the least amount of code possible that you can write. The more code that you have, the more liability that you have, the more stuff you have to maintain. And then with the way that the direction that I see the entire industry is heading, the more that you have a expertise in front end, the more valuable you're becoming, the more you're getting paid these days, the more sought after you're becoming. So what does this infrastructure do? It provides tooling. So if you want to prescribe to this, like what do you expect? It provides tooling for creation and configuration of cloud services from any provider. It doesn't have to be AWS. It provides access to cloud infrastructure via a mobile or a front-end client library. So it gives you a library that you can use to interact with these services. It generates code for you, not only on the client, but also on the back end. It basically enables developers to move up and down the stack a lot more easily with a lot less friction. And you can do this using just a single skill set or a single programming language. And the number one way that people are building these applications right now is definitely JavaScript. So what are some of the tools that you can use to build this? The one that I'm going to be using and focusing on today, since I work at AWS, is AWS Amplify. It's not the only way, though. Ionic has the Ionic toolkit. There's also Jamstack, which I would say fits into this paradigm in some fashion. There's Firebase. There's Zeit with Next.js. Zeit is basically now offering a lot of serverless type of services. And Jamstack is basically JavaScript, APIs, and Markdown. Firebase, you've definitely probably heard of Firebase. So the AWS Amplify framework is what I'm going to be using to build the application that I'm going to be demoing in just a second. It's has three main parts: a CLI, a client, and a hosting service. So the CLI is what you use from your terminal to create the different cloud services that you want to work with. You can also create and manage multiple environments. So you create a service, you create an application, you deploy it, you want to test out a new feature, you can just check out a new environment. This clones your entire environment into a new environment. You make changes, you can then diff the two different environments to kind of see what you would like to merge into your main environment. We also have a tool chain that does GraphQL code generation and GraphQL transform library, which I'll demo in just a second. There's also the client library. So you use the CLI to create the services. The client then connects and interacts with the cloud services. We have pre-configured components for popular front-end libraries: React, Vue, React Native, Ionic. We also have just a completely open JavaScript, native iOS, and native Android library. And it's open source. We also launched the console just a few months ago at reInvent 2018. It is a hosting CI/CD pipeline. And we have a lot of different features. I would say we've added dozens of features actually since we launched. This is a few of the most popular features. But basically, if you've ever used anything like, I think Netlify has something similar to this, where you can just launch and deploy your application from the command line. This is it. And interacting with it in the console. And then this is kind of like what the console looks like. So what are some of the features that you can enable with Amplify? This is a list of some of the most popular ones. The ones that I'm going to be demoing today are authentication. I'm going to be demoing a GraphQL API. I'm going to be demoing a database with the API, which kind of comes together actually. And I'll also maybe touch on serverless functions. Those seem to be the most popular ones anyway. And there's a lot of documentation, a lot of stuff about what I'm about to go over. So if you kind of want to recreate any of this, I'm going to give you some links at the end to kind of be able to do that. So getting started with Amplify, you first need to install the CLI. So you npm install it. After that's installed, you can then initialize new projects. So the workflow would typically look like this. You create a React app, you create an Angular app, whatever your native iOS app. You're in the root of that project. You then initialize a new project by running amplify init. So this is done within the front-end project. After the project's been initialized, you can add features by running amplify add. So amplify add auth, amplify add API, and then amplify push will actually create the service in your account. With the front-end libraries that we have, like I mentioned, Vue, React Native, all of that stuff, you can also npm install those depending on the environment that you're in. So if you want to add the React Native client, you can run npm install AWS Amplify -React Native. That would be -Vue, -Angular, depending on the framework that you're working with. And then once you've created the service, you've installed Amplify, within the JavaScript, you can then just import the components that you want to work with. So this would be a way that you could work with auth. Auth has about 30 different methods on it. So you can call auth.signin, sign up, sign out. You can call forgot password. You can change the multi-factor authentication type. You can add time-based one-time passwords. You can do all kinds of stuff. This is just a look at the frameworks that we support. And then I mentioned that we have these framework-specific components. So this is what one of them is that I'm going to be using today, the with authenticator. So a lot of times, if you're building an application, you want to spin up authentication maybe just to like test something out, or you just want to have it up really quickly. You don't want to write out all of this boilerplate code. But you know that when you create authentication, you need a couple of different features every time. You need a way to sign users up. You need a way to sign users in. You need a way for them to retrieve their password. You need a way to store their data in the session or in the async storage on React Native or native iOS or native Android in the platform's storage, and retrieve the user maybe when they close the app and open it back up. So all these things are repeated over and over and over. With Authenticator, basically provides all this functionality out of the box, and you can put it in front of whatever component that you want to work with. So I'm going to be working with the main app component in a React Native app. With 2 lines of code, after you import it, it adds all this in a pre-configured component that looks something like this. And you get all of that protecting your application, and you can then work with the user's data after they've logged in. And you can password protect your applications. So this is how to work with multiple serverless environments. I'm not going to go into that right now. I may actually demo that in the actual demo. So for the demo, we want to create an example application that has a couple of different features. We want to have user management. We want to have an API. We want to have search. We maybe want to have analytics. With the user management, the authentication part comes in, and then we want to maybe do some authorization on the data. So for instance, when we store data, we want to reference something about the user that's creating that data. When we query for the data, we want to be able to retrieve user information about the user in the request, and then maybe do some logic on the data that's being retrieved. So what are we going to do this? We're going to be using Amplify categories of auth, API again for search, and then analytics for analytics. So let's go ahead and test this out. So I'm going to go ahead and open up my console, and we're going to try to build out this application. So I have this in 2 steps. Let me go ahead and make my font a little bit larger, or a lot larger. Okay. So I'm inside of a React Native project. After I've created the React Native project, we run amplify init. This will generate the Amplify folder in the AWS exports file for you. And then from there, you can start adding new features. So I mentioned the features that we want to add are an API, we want to add analytics, and we want to add authentication. So to do that, we would run amplify add, and then the name of the feature. So I'm going to say amplify add auth. So after we add authentication, we have the option to choose a default smart configuration that gives us multi-factor authentication on sign up. And then when we sign in, we only need the username and password. On sign up, we'll be capturing the username, password, email, and phone number of the user. If you'd like to set up a different type of configuration, you can choose no, and this will just walk you through a series of steps. You can set the MFA type. You can capture other metadata about the user or whatever. But for the demo, I'm going to be choosing the default. So after we've done that, it's actually gone ahead and added the resource for us. So we can run amplify status. And we should see now we have an auth category whose operation is set to create. This basically just means that we have not created it yet. When we run amplify push, the operation category is what's going to be referenced. So after we've added a authentication, we want to now add an API. So when we run amplify add API, we're given two choices. We can either add a GraphQL API, or we can add a REST API. The GraphQL API is built using AWS AppSync, which is a managed GraphQL backend. Similar to Firebase in the way that a lot of people use it, it's basically a way to have a backend spun up, managed for you. It's serverless, it scales for you. We have a bunch of customers using it at scale. And then we have the option for a REST API. The REST API is going to give us two options. So we basically have three options, one for GraphQL, two for REST. For REST, we can either do a DynamoDB table, API gateway, endpoint, and a Lambda function. That will all be created for us. Or we can choose just a Lambda function with an API gateway endpoint. And we'll also spin up within that Lambda function an entire Express application. Like we'll just spin up the boilerplate for you. You can then kind of write your own code. So this is kind of like three different options there. So if you've ever wanted to get up and running with Lambda serverless stuff without having to actually go into the console, this is one way to do it. But anyway, we're going to choose GraphQL. And the API that we're going to create is going to be like a conference API. We want to create an app that allows people to create a conference app, log in users, or not log in users, well, yeah, log in users, but we also want to have talk names, speaker name, speaker bio, that type of stuff. So something like for the conference that we're at. So I'll give this talk like Pixels Camp API. So now we can choose an authorization type. The two that we're given here are API key, which basically means that this will be open to anyone that sends the key in the request in the header. Or we can use Amazon Cognito user pool. Since we've already added authentication using Cognito, we can actually just choose this, and it'll automatically configure that for us. There's one other authorization type that we can choose, and it is OpenID Connect. So if you have Auth0 or Okta or even Firebase, if you've rolled your own authentication, you can just bring that, and we can use it here as well. Do we have an annotated GraphQL schema? If you have a schema, you can reference it, but since we don't, I'm going to choose no. And then it's going to ask us if we'd like to have a guided schema creation. If I choose yes, that will give us three options to use. These are going to be three boilerplate schemas that we can start and work with. One is just a really basic object with fields, which is basically a type of to-do with a couple of properties. And then we get a little more complicated with the next one, one-to-many relationships, basically allowing us to create a schema that can have many-to-many relationships. And then finally, we have objects with fine-grained access control. I'm going to just choose single object with fields because we're going to be writing the schema from scratch anyway. And then now we can go ahead and edit the schema. So this is going to open up our editor of choice with a base schema. The schema that it's giving us is this to-do schema, but we want a conference app, so we can't really use that. So what I'm going to do is just use a schema that I saved earlier called talk. This talk type will allow us to create an array of talks, query for a single talk, do subscriptions in real time when someone creates a talk, so on and so forth. The three main fields that we're worried about are the talk name, the speaker name, and the speaker bio. So I'll go ahead and save that and close this. And after I hit enter, this is going to go ahead and create that configuration for us locally. So if we run amplify status again, we can see that we have the new category added. And finally, I'm going to go ahead and run amplify add analytics. Well, actually, I don't think we want to do analytics. Well, might as well test it out. I'm not going to be able to demo this because I don't think we have enough time. So I'll go ahead and run amplify add analytics. I'm going to go ahead and give this a resource name, something similar to the name that we're using here. We can go ahead and allow analytics events. Now, if we run amplify status again, we have these three resources created for us. So finally, to go ahead and create this stuff in our account, we need to push it up so we can run amplify push. It's asking us if we want to continue, and it kind of prompts us with the operations that are about to happen. We can choose yes, and this will go ahead and create everything for us in our account. Now, before that happens, it's going to recognize that we're creating a GraphQL API. So it's going to prompt us for another series of questions. We can generate the GraphQL code that we're going to need on the client right here in the CLI. So if you already have this code written, which you probably don't, you can just choose no, but since we don't have it written, we're going to choose yes. Typically, when you have a GraphQL API, you have a series of operations done against the schema. So you'll have things like mutations, queries, and subscriptions. A query might be to get an item by ID or get a list of items. A mutation might be to create, update, or delete. All of the CRUD operations that you might be used to on a REST API, we have similar corresponding ones sometimes on GraphQL. And whenever you want to actually interact with your API, you have to write that query or that mutation from scratch. We're basically going to introspect your schema and then generate all of those operations locally. So you don't have to write any of that code. We'll write it for you. And then you can write it in JavaScript, TypeScript, or Flow. I'm going to choose JavaScript. And if you follow me on Twitter, you'll see stuff like this about me and TypeScript. Anyway, I'm going to choose JavaScript. So we can now enter the file pattern. So if we want it to be in a folder called GraphQL or not GraphQL, whatever, we can choose that. We want to generate all of the operations, yes. We can set a max statement depth by default. This basically means we want to prevent malicious queries from going more than 2 levels deep. So when you're working with GraphQL APIs, you might have a relationship that looks something like a book has an author that has an array of books that has an author, and someone can submit a query that goes 1,000 levels deep or something and break your API. So a lot of times you'll set a default max statement depth. So we're just going to choose 2 for the default there. Okay. So after that's done, we're going to have let me go here. And we're going to look again. We still have this Amplify folder, and we still have this AWS exports file. But if we run Amplify status now, my computer froze up. I'm going to restart my terminal. Sorry about that. Oh, okay. I have no idea what just happened. Anyway, we run amplify status. We see operation no change because we now have created those resources, so there's no need to change those. We're also given some stuff like our GraphQL endpoint. You don't really need that. We have that created and configured local for you in this AWS exports file. This file holds all the configuration for your project. You don't ever need to edit it, but it has things like your API endpoint. If you create a Lambda function with an API gateway, it'll give you the API URL there. It gives you some other stuff like the client ID, which allows you to create users in your Cognito account and then log in to the AppSync console as that user and simulate the user to do testing and stuff like that. So this AWS exports file is pretty important, but you don't really need to use it. It's just there for reference. And then the rest of the app is just a really basic React Native app. So you've probably seen this before if you've worked with React Native, just like a hello world, using this instructions variable here. So what we want to do now, since we've added these features, we want to actually implement those in our app. So the first thing you want to do in a JavaScript application is run amplify configure at the root level. At the level of index.js in a React or React Native application, you import amplify from the amplify library. You import that configuration that we just looked at AWS exports. And then you call amplify.configure, and you pass in that configuration. And that's pretty much it. You just save that, and then now you can start interacting with Amplify. So after that's been saved, I'm going to open app.js. We first want to add authentication. So what I'm going to do is add authentication using that higher order component I mentioned earlier. So to do that, I'm going to go ahead and import the with authenticator component from Amplify React Native. Instead of the default export being the class, I'm going to change the default export to be the with authenticator component. Oops. So we're changing the default export from being just the app. We're now wrapping the app in this with authenticator component. And then we're passing in a second argument of an object. Here you can define how you want your with authenticator to look, what properties and things like that you'd like for it to display. The only thing I'm passing in is this include greetings flag. This just will put a sign out button. So it's kind of like this, we're calling it the greeting. I'm not sure if that makes sense, but that's the way they labeled it. So now I'm going to go ahead and save that. And if we refresh, we should see that we have an authentication flow put in front of our application. So we can sign up, we can sign in, we can forgot password, we can do all the basic stuff that you might need. So I'm going to go ahead and create my account. I have to make sure my email is right because it's going to send me a multi-factor authentication code. So after we've signed up, we need to check our email. All right, so we'll copy that code that comes in, paste it here, and now we're signed up, so we can now sign in. This is the easiest way I've ever done authentication in my entire life, by the way. I'm not just saying that because I work there, it's pretty cool. So now we have authentication put in front of the app. If we refresh, we notice that the user session is persisted. That's because we handle all that stuff for you. We're working with async storage on React Native, again, local storage on web. The only way to sign out is to call auth.signout, or we could click this sign out button that does the same thing and re-renders the state. So now that we're signed in, we have a greeting that just kind of gives us the name of the username that we are. If we'd like to, we can actually also call the auth class from Amplify to get all of the information about the user. So we could import auth from AWS Amplify, and then in component did mount, we could do something like this, where we call auth.currentAuthenticated_user. This will basically return null if the user is not logged in, and it'll catch by throwing an error. And if we are signed in, we'll get this user object, which we can then just log out. So let's go ahead and refresh and see what that user object is looking like. So we have this user here that has all these different properties that you could kind of use in your app. Typically, you're going to work with the metadata that's in the, the ID token payload. So here you'll have things like their email, their phone number, their username, but you might also have other metadata that you've asked for the user and stored there as well. So their favorite color or whatever you want to get from them. Okay, so now that we have authentication, we want to add the actual API part. So we want to be able to list data from the API. We want to be able to create data as well. So we want to be able to interact with our GraphQL API. The way that we'll do that is we'll first import the imports that we're going to need from AWS Amplify. So the two main APIs that you use to interact with GraphQL are going to be API and GraphQL operation. API is the GraphQL client that we're working with. You can use this also with REST APIs. You can use this with non-AppSync APIs, so it doesn't have to be AppSync. You can use this with Apollo. You can use this with Prisma, whatever. So that's what API does. And then GraphQL operation is basically a helper that allows you to write your GraphQL queries, mutations, and operations as strings, and then it basically will transpile that into GraphQL AST. Then we have a couple of components from React Native Elements to make our UI less verbose. So we have a button and a form input. And then finally, I mentioned that we even looked at actually how the Amplify client or CLI generates all of that GraphQL code for you. If you look here, we're importing from this GraphQL folder queries, mutations, and subscriptions. So if we go there, we look here in GraphQL, you'll see that we have all this stuff that was generated for us. So we have get talk, list talks for queries. Subscriptions, you have a way to subscribe to when a talk is created, updated, or deleted. So I'm not going to spend too much time there. This is just code that was generated for us that we're importing. So that's basically it. We import the components, and we import the UI items, and we import the actual definition of the query mutations and things like that. When the app loads, we want to first hit the API, query for all of the data that's there, and then update our state. If you've ever worked with GraphQL in the past, you may have worked with something called Apollo or React Apollo. We have a separate library that mimics their API, and it's actually a fork of Apollo client that we've built on top of. That is our other way of doing this. The way I'm doing it today, though, I'm using the Amplify library, so we're actually going to be calling the API directly. You could instead, again, use React Apollo with the other SDK and use things like higher order components and things like that. Anyway, so in component did mount, we're going to go ahead and we're going to call api.graphql. And then the return value we're storing in this variable called talk data. This is going to have a property called data on it. And then within that, we're going to have a next token that allows you to do pagination. And then we'll also have a list talks property, which is the data returned from our API. The data that we want is the items array. This is a convention that's GraphQL in general. When you return an array, you have a name for it, and it's items. So we're basically saying we want to get all of the talks and stored in an array, and then we call set state. So I guess if we want to set the state, we need to create some state. So the state that we're going to be creating for this app is name for the name of the talk, speaker name for the name of the speaker, and speaker bio for the bio of the speaker. And then we're going to have an empty array of talks that will populate when the app loads. We'll also be doing an optimistic response. So when we create a new talk, we'll go ahead and update that talks array. So we have done all that. So now we need to create some methods that will allow us to update the state. So the two methods that we're creating are onChange and createTalk. If you've ever written a form handler in web or mobile, You know this is a pretty basic operation. We're just saying as the user types, update the state with the key and the value. In this case, it'll be username, not username. It'll be things like talk name and speaker name and those sorts of things. And the value will be the value of the form input. The only other method that we're creating is the createTalk method. This takes the state and creates an object called talk, where we set the name, and speaker bio. We then create a new array of talks with the existing array of talks in the state, and we pass in the new talk. Then we call setState, clearing out the form, and updating the talks array. So we're doing the optimistic response right here. And then after we've updated the UI, only then do we call the API. And we do that by calling api.graphql again. When we called api.graphql earlier, we passed in the GraphQL operation helper and the query. So we only passed in one argument, which is the query. But when you're creating a mutation, you actually have to pass in a second argument, which is the input for the mutation. So here we have api.graphql. We're calling the GraphQL operation with two arguments. The first is the mutation definition. The second is the input, which is the name of the talk and the properties of the talk. So very similar. We're calling api.graphql for the query and for the mutation. The main difference is we're passing in some values as a second argument for the mutation. And that's about it for the actual functionality. The one thing we need to do now is create the UI. So the UI is going to be super, super basic. It's just going to be a bunch of form inputs. So really nothing that you haven't seen if you've ever done this type of stuff before with web or any type of forms. It's just really basic stuff. 3 form inputs and a button to call the method that we created a second ago called createTalk. Finally, we have a scroll view that maps over all the talks in the array and displays the talk name, the talk speaker name, and the talk speaker bio. And last but not least, we're going to want some styles that are not these styles. The styles are not really important, just styling. And I guess one other thing is, since we're using scroll view, and this is a new React Native app, I don't think I've imported that. So let's go ahead and import that here. All right, we'll try this out. The app loads. We still have our button, but now we have a form. And I'm going to go ahead and open the debugger, because when we create a new talk, we're going to log out some success message. So the talk name is, what is it? All right, so we create the talk. We get the response here that the talk was created successfully. We refresh. We call the API. The data comes back. It's kind of slow for some reason. But anyway, so we're getting the data from the API. So if we create a talk 2, create talk. Talk successfully created. We refresh. We see that our talks are there. The last thing we want to do now is we want to add real-time functionality to this. So we want to add subscriptions. Basically, what that means is after the app loads, if someone else adds a new talk, we want our UI to update automatically. Prior to using GraphQL subscriptions, a lot of times to do this, you could use Firebase, or you would have to write something around with WebSockets. With GraphQL subscriptions, though, this is pretty easy. You just subscribe to changes in your data. Typically, the changes are event-based. So when something happens, then do a subscription trigger. So normally, you're going to be doing those on the types of operations that would be considered CRUD operations. So when a talk is created, when a talk is updated, when a talk is deleted, we can subscribe to those different things. And if you look in the folder in GraphQL, we've actually created all of those subscription definitions for you. So we're going to subscribe to onCreateTalk. So when a new talk is created, we want to subscribe to that. And the way that we're going to do that is we're going to go in component did mount. And And we're going to be writing this code right here from line 18 to 35. So we call api.graphql again, just like we did before, but instead of waiting for an asynchronous response, we're calling .subscribe here. And .subscribe will ask for a next function that we have to define ourselves. So we say the next function will do all of this stuff here. What we're doing is every time this subscription is fired, we'll get an argument that I'm calling data. That's going to be the subscription data. So if we subscribe to a new talk, the data will be the new talk. We destructure that talk from the data because it has some other properties on it as well. We then do some really ugly filtering because I didn't create a client ID here. And we update the state. So we're basically taking the application, loading it. When a new talk is created, that object basically comes down. The object has a talk name, speaker name, all that stuff. We take our array of talks, we throw the new talk in there, and we call setState, update the UI. So that's kind of how the subscription works in this instance. You can also, again, be using React Apollo that will handle this a little differently in either a higher order component or a render prop. So how do we test this out considering we only have one device? Well, I'm going to actually go into the console and show you around there real quick. We're running close on time, so I'm going to try to do this in the next 3 minutes. I'm going to take the client ID, and I'm going to log into the console to AppSync. I'm going to find the app that we just created. And I'm going to go to queries. I'm going to log in with the user I created earlier. And I'm going to go ahead and create a new talk. And I'm going to keep my device here open so we can see it. This is going to be a talk called real time, because this is a real-time demo. The speaker bio is going to be speaker bio. All right, so we'll go ahead and trigger this. When we trigger this, the UI of our app should update now. So go ahead and create. Boom, there it is. So we now have the real-time functionality built in. I mentioned also we can do filtering or searching, so how would that look? In the query of list talks, we can pass in a filter. The filter would be the way that we want to filter for that. So if we want to look at the documentation, we can actually click on the right-hand side, go here. We want to filter on the, maybe we'll filter on the talk name. And we want it to contain like real or something like that. We can then query for that. We only get a single talk back. If we remove the filter entirely, we would still be getting the entire list of talks back. So that's kind of one way to do filtering. And we've actually implemented all of this stuff on the client for you as well. So you could like write this code on the client by just passing in the filter argument. So that's kind of it. I didn't get a chance to go into some more stuff because we're running low on time. But if you go to any of these resources I'm about to show you here, you can see a lot more about all of this stuff. So there's the AWS Amplify docs, which will be the first place to check this stuff out. The second is Awesome AWS Amplify, which is a repo that I maintain. I keep all of the videos that I can find, all of the documentation that we have. I also find all the third-party stuff. So if someone's written a tutorial out there, we have a lot of different stuff from the community that we put in there. We also have the AppSync community, which is similar to Awesome AppSync. I'm sorry, it's similar to Awesome Amplify, but it's for AppSync in particular. I wrote a blog post called Full Stack in the Era of Serverless Computing. That's been pretty popular. That kind of goes into depth on the philosophy part of the beginning of this talk. And then there's a new blog post called Serverless State of Mind, and it's written by Ben Kehoe. It's a really good blog post that kind of goes into this philosophy as well. And thank you, that's it. I'm Dabit3 on Twitter. If you want to follow me or ask me questions anytime, I'd be happy to help. Thank you.